Design thinking is a buzzword pair that's been floating around for some time now. For most people, it conjures up images of some new product they remember hitting the market. But for others, it's the way to tackle problems. So what is it about design thinking that makes this approach to problem solving so unique and so effective? Design thinking, unlike other problem solving approaches, doesn't start with the available choices. It doesn't ignore them. It just doesn't start there. Step 1. Observation. Design thinking begins with observation. Much like the scientific method, design thinking requires a period of close observation. What the participants are looking for are patterns and behaviors so that they can begin to ask questions. We often play this out in our daily lives when we thoughtfully ask, I notice, I wonder. It is this wondering that leads us to step 2 of the design thinking method of problem solving. Step 2. Ideate. In case you're wondering, this is where the Post-it notes come in. During this phase, the participants need to get all the ideas out there. This isn't the time for shutting ideas down, no matter how strange or implausible they may seem. The reason behind this step in the process is that it's unlikely that at this phase the answer is out there. If it was, the problem would already be solved. What needs to happen is that the ideas need to meet and get to know each other. It's when these ideas begin to collide that innovation starts to happen. Step 3. Prototype. Whether you're designing an object or trying to solve a social problem, you need a model. What does your solution look like? How are all the moving parts going to fit together? While this step doesn't require perfection, it should be close to what you expect your end product to look like and function like. But most importantly, does it solve your problem? Step 4. Test. Before you test your prototype, there are a few things you should remember, the most important of which is that failure is totally okay. We often learn more from our failures than we do from our successes. You should also take steps to define what success and failure looks like. If you don't know what the working model looks like, you will never know if you've solved the problem with your prototype. Same is true in the case of failure. This one needs careful consideration. Sometimes our ideas just need tweaking, and sometimes we really need to go back to the drawing board and start again. If we have clearly identified failure markers, we can save a lot of time and frustration. It's better to move on than get trapped in a cycle of diminishing returns and never actually solve the problem. But if the test goes successfully, why not try and make some improvements? The process of iterations, little tweaks along the way, can really take your solution to the next level.